Welcome everyone. I'm Ira Feldman. Welcome to today's webinar, Semiconductor Test Consumables, The Road Ahead, sponsored by SW Test, Test Connects, and VLI Research. Welcome, good afternoon, good evening, good morning, wherever you may be. Welcome to today's webinar. This is session 2. So this is the repeat of the slides from this morning, but it will be a very interactive session. So we encourage your questions via the Q&A tool as we present, and the person moderating will ask the presenter the questions. So these could turn out to be very different presentations depending upon the questions that you ask. So welcome. And so the agenda is Jerry Brose will present the semiconductor test overview, followed by myself talking about tests and test consumables market report, and then John West will close with the changing cost structure of semiconductor test. My great pleasure to introduce John West. John has over 20 years of experience doing data and analytics related to semiconductor manufacturing, in particular semiconductor test, the probe cards, test and burn-in sockets, device interface boards. John holds a Bachelor of Science degree in medical physics from King's College London and an MBA from Cranfield University. And we are very happy that John doesn't mind getting up in the middle of the night. So thank you very much, John.
And today I'll be talking about the changing cost structure of semiconductor tests. Now, my assumption is that if you're on this webinar, you are either a buyer or a user of test equipment or test consumables, or you represent a company that supplies those products. So in this presentation, it should help you understand what the cost structure of semiconductor tests looks like today, how and why that's changing, and more importantly, what that means to you and your businesses. So with that, I'll start. So first, we need to talk about the market environment. Now, I know Jerry and Ira spent quite a bit of time talking about this, so I've just got one slide to really explain what we know for sure. And the one thing we do know is that the fundamental market drivers to semiconductors haven't changed. So big data, AI, machine learning, 5G, all of those drivers are still in place. And most of those programs, the infrastructure programs, so that's seeing a little softness in automotive or some large industrial applications, maybe a little softening in some consumer electronics, but the really big drivers are still there. And we know that because the industry right now it's processing a lot of wafers, it's producing a lot of chips, and all of those chips still need testing. So there's a lot of work for us still to do right now. We're very fortunate in this industry that with COVID-19, it seems that nothing's really changed. It's not exactly business as usual, but the demand for our products and services are still there. Something else that we do know about COVID-19, it really hasn't changed the technical problems for semiconductor tests. They still exist. They're not going away anytime soon. And every time we solve one problem, we know there's another one waiting for us to tackle. And I suppose one of the other things is that the economic challenges just got a little harder. So we have to be very careful about how much semiconductor test is going to cost us. Now, I know everyone talks about, this industry hasn't really been impacted by COVID-19 too badly because sales are flat to up a little bit right now. It has, because if COVID-19 hadn't come, we would have been looking at probably +10, +20% growth in the semiconductor industry. So it has had a negative impact, but still compared to other industries, we're doing very well. So first, let's look at what's happening in the short term. So this chart shows weekly semiconductor sales compared to the same week last year. So this is a great data set because by looking at weekly data, we can get 52 data points in a year to really try and figure out what's happening. And essentially what this is telling us is that last week, compared to the same week last year, semiconductor sales were just down a little bit. But actually, you can see really from November last year, yeah, semiconductor sales have been higher than they were in 2019. And in fact, and again, Jerry showed you the data from WSTS, is that Q1 was coming in like 10% higher than 2019. And we're saying even Q2 is coming in at a roughly the same level. So yeah, essentially the first half of 2020 is already 10 to 15% better than it was in 2019. So we know that business is improving, and that 2020 should be quite a good year. But you can also see from the chart is that there's a lot of volatility. You know, one week we could be 35 to 40% higher than the same week last year, and in the next week we could drop down to minus 15. So there's a lot of volatility here, which, you know, it is an example of the uncertainty. But overall, the trend is definitely positive. So what about the long term? So throughout the year, actually since COVID struck, you know, I think like everyone as analysts, we were always looking on the negative side. Okay, this is going to be bad for us. We were putting in some really big negative numbers. But every month that's gone by, we've been increasing our forecast for 2020 because the numbers are coming in way better than we even expected. So in April, we were looking at maybe minus 4% for the year. And by June, we were pushing it up to plus 2%. So, you know, we're seeing strong demand across all sectors. And in fact, if we look at actually a lot of this growth is coming from NAND. We're seeing double-digit growth for NAND chips in 2020. So that's the main thing that's driving this positive growth. However, having said that, you know, growth for advanced logic, foundry, DRAM, they're all showing signs of being slightly positive for 2020. So this year, as the year has progressed, it's getting progressively stronger than we thought. But again, overall, if we look at the long-term growth rate for semiconductor revenues, we're still looking at that 6 to 7 to 8% long-term growth trend, and that hasn't changed at all.
So John, how much of the short-term and maybe influencing the long-term numbers is people just building up inventory just in case, you know, of a fab being down for COVID or something like that?
Yeah, so we've taken a long look at this and spoken to a lot of people. So yes, everyone's moved away from a just-in-time to a just-in-case inventory model. You know, clearly having just 1 or 2 days inventory is no longer acceptable. So what we see, and again, the people we've spoken to said, well, we're not panic buying, we're not hoarding chips. Essentially, we're going back to traditional levels of inventory. So going from a few days to a few weeks, that's all. They're not getting in 6 months or a year's worth of chips just in case, because it's like a lot of things, is that the chips have a certain shelf life. You don't want to overorder them and then find out that either they become redundant. So there's this balance to be made. But you are right, it is something that we did look at very carefully, because if there are huge inventories out there, then yes, as soon as the market dips a little bit, that could have a very rapid impact on semiconductor demand. But we're not seeing that. We're just seeing just a little bit of extra inventory just in case. So nothing to worry about at the moment. So clearly this year's coming in quite strong, producing a lot of chips, and these chips need testing. So, you know, and the question is, where do you test? So there's multiple places where you can test a die, I mean, whether it's a wafer, package test, burn-in test, or system level test. So you know, the industry's got options here about where to test, how much to test. Are we going to test everything? Are we just going to test in 1 or 2 places? So there's a lot of options for the industry. And I thought it'd be interesting this time really just to show, you know, what the costs of each of these areas of test are, just to put things into context. So for 2019, this is how it looks, how it plays out. So if we look at the amount of money that the industry is spending on test hardware and consumables for wafer sort, for example, and that includes ATE, probers and probe cards. About 42% of the cost of test is at wafer sort. For package test, and this includes ATE, test handlers, test sockets, and device interface boards, about 40%. Burn-in's relatively low there with the burn-in ovens and burn-in sockets and burn-in boards. And now we have a new area, the system level test, which is coming in around about 12%. And that includes test equipment, test handlers, test sockets, and the test boards there. And really, the system level test is something new. System level test has been around for a long time, but it's been very, very difficult to measure. And this is really our first attempt at getting some sense of just how big this market is. Now, if you add all this together, it comes up to $10.4 billion in 2019. So that's a lot of money for the industry to be spending on tests. And I'll show you later as well, this $10 billion represents around about 3% of IC revenues. So the industry is spending around about 3% of its revenues on test. And the question is that okay? Is that a reasonable amount of money to be spending on test? And we'll talk about that a little bit later on. But essentially, what I'll be showing you later is that the cost of test is going up, and it's putting a lot of pressure on the economics of the industry. So not only is this big, it's growing. It's growing around about that between 4 and 6% CAGR over the next 5 years. And for the industry, this is a massive problem. But well, it depends on where you are. If you're a supplier, this is an awesome outlook for you. You're looking at really good, strong demand drivers. Your business is going to grow 5, 6, 7% year over year. This is great if you're a supplier. But if you're a buyer, this is a huge headache, because not only have you got increasing cost of tests, you've got costs across the board for semiconductor manufacturing are going up. And this is just another one of those areas that is causing serious issues for the industry. Is, am I spending too much on tests? Is there any way I can get my cost of test down? Where is this? What's driving this cost up? So these are all the kind of questions that we're getting asked as analysts. Is what can they do if anything?
So John, especially on there's a question here, especially on the capital side with there's the huge historical peaks and troughs, especially on the CapEx side, which may be a little smoothed out in this graph where you put the consumables layered in. The question being asked is, will the pandemic push the industry back to these, to the roller coaster? The last few years has sort of been steady, but you see a lot of ups and downs due to the pandemic.
So I think, if you look at the major downs we've had, there was the dot-com bust, like 2001, and then we had the financial crisis. So they're like truly exceptional events that actually did, drive down CapEx quite significantly. But in other areas, it's not. In recent years, CapEx has been pretty, I wouldn't say stable. It's been volatile, but less volatile than it has been in the past. So we've been seeing pluses and minuses of like the 10, 20% range, which is okay, not the plus or minus 50 or 100% that we've had in the past. So yeah, I'd say CapEx is volatile, but less volatile. And a lot of that is due to the fact that, the CapEx is really in the hands of like the top 5 chip makers. Those guys account for like 70, 80% of worldwide CapEx. So, it's less likely to have these big fluctuations in demand for capital equipment. We have, so this year, actually, so this year for CapEx, we've got it up 6% already. For wafer fab equipment, it's looking like it's going to come in plus 8%. So this is meant to be like a difficult year for the industry, yet chip makers are still powering through, carrying on with their investment plans. Our models show there's likely the next likely cyclical downturn is most likely to be 2024 is when there may be a downturn. And again, it's very difficult to predict exactly when these things happen. But yeah, we would expect probably 2024 to be the next down year. Anyway, I hope that answered the question.
Yep, and one more question came in. If you want to comment on sort of the distribution between, test hardware and consumables, is there a ratio that's typical, or anything you want to comment on that?
I'll comment a little bit on one of my other slides later on.
Okay.
And
Okay.
I'll see if I can fit an answer into one of my slides. Okay.
So John, I have a question. I'm going to kind of put you on the spot a little bit. So in looking at 2021, the probe card market was expected to be kind of soft with a growth of less than 1%. And then I looked at Ira's slide for 2021. The socket market is basically expected to be in the 20% growth range.
Yeah.
So how do you reconcile these big differences? I mean, probing, you got to test the stuff. Socketing, you got to test the stuff.
Yeah, so those were two different forecast periods. So
he was pretty optimistic when he gave me the forecast.
So Ira's forecast was done right at the very beginning of COVID, when we were starting to think, okay, how's this going to play out? So essentially, and again, you need again, essentially what's happening, the fundamental demands for semiconductors are still there. So whatever we don't sell this year, we're going to sell next year, or the long-term trend says that if we're below trend this year, we're going to be above trend some point in the future. So essentially that's what's happening. And I think our current socket forecast is flat for this year, and then plus 10 or 12%. And it's the same thing for probe cards right now. Probe cards are going to definitely come in positive. That kind of maybe 5% is what it's looking like at the moment, followed by another 10, 12% growth in 2021. So it's all about timing. It's a rapidly changing situation, but it's one that's improving, day by day. But yeah, essentially you are right. Is that if you've got every wafer you produce has to be probed, and every die on that has to be socketed somewhere. So yes.
Yeah. So historically, do you see a kind of similar growth rates with the probe card consumables and the socket consumables? Do they sometimes match each other? Are they parallel to each other? Is there a big difference between them?
So there is some divergence. Probe cards are getting more expensive. I mean, just seriously, the challenge of high pin count, high pin density is just getting really very, very difficult and very expensive to solve those problems. And the same problems exist for sockets, but I'm assuming there's those challenges are probably a little less challenging. Maybe I'm not being fair there. But again, one of my later slides, there is an argument that maybe some of that package test may be shifting off to system level tests. So those costs are showing up elsewhere. But yes, probe cards, and again, it's one of those interesting things in that wafer sort area. The probe card costs have been going up, and the ATE has been going down. So it kind of looked okay as an overall picture, but now ATE is starting to flatten off, and it's actually starting to grow as ATE expenses are starting to go up, and then that's starting to show up in the data later as well, which is driving up that cost for wafer sort. But it's a real problem for the industry, is that cost to test is huge, and it's growing. And one of the questions I would, as a chip maker, you've got to ask yourself is like, can I afford my current test strategy? And I think this next slide pretty much tells you what the situation's like. So this is showing test hardware, test consumable costs as a percentage of IC revenues. So essentially, it's between that 2 and 3% of IC revenues. Now, to give you a bit of context here, from 2000 all the way to say 2012, there was a clear reduction in this percentage from around about 4% back in 2000, and it's been gradually declining to just above 2% in 2012. And the industry's been able to do that by the emergence of OSATs that were able to improve the utilization rate of testers. So that was one thing. Moving to parallel testing was another cost saving, if you like. So all of that 10, 12-year period, there was the test equipment, test consumable guys were doing a really good job in managing the cost of test. But clearly something has changed since 2013. The amount of money that chip makers are spending on test is gradually growing up. It's gone from like 2.2%, and it's getting pretty close to 3% now. And we know that's true because this is all measured and validated. So this has actually happened. And the question is, for any company, if one of your costs is growing, it's going to start cutting into your profit margins. So action has to be taken. Now, the part of the chart in the gray area, which is our forecast, we're assuming that the forces of economics are going to come into play here, and the industry will be able to get this cost of test back down to like a 2.5%. 2.5% seems about right as a number. I don't know how the industry is going to do it. It can do it one of two ways. One is they can become more efficient in testing, or cutting the cost of their, spending less money with their suppliers, or it could be that they just have to pass that cost on to, the end consumers. So that would result in higher chip prices, and we know that's not really an ideal scenario, because if you increase chip prices, then demand for chips goes down. So it's one of those situations. But all of our models tell us that somehow the industry has to find a way to get this cost back down to 2.5%. So one of the things I think is kind of helpful is we break this data down into the 4 different test areas to see where the problems are coming from. So if we look at the same data broken out by test area, we can see what's been going on. So really for wafer sort package test, that's been growing. That's been most of the problem. The costs are going up. And the question is, why is that? What can we do to get that down? Burn-in test seems to be okay. It's been fairly flat and it's kind of trending downwards. So it seems there's not a problem with burn-in test. But here's the thing: we've got this emergence of system-level test. Is really complicating the situation, because not only have we got wafer sort and package test costs going up as a percentage of IC revenues, we've now got an additional cost coming into play here. And it's causing a lot of problems for the industry, because these trends are not really sustainable. Something has to happen to get these costs down. So if we look at the right-hand side of the graph, which is the gray area, which is our forecast, all the economic models are telling us that wafer sort and package tests should, at the bare minimum, start to flatten off. But because we've now got this system-level test coming in, for the economics to make sense, we really need to see wafer sort and package test costs come down somehow. And this is putting a lot of economic pressure on the system. And there's a real issue for the industry is, how do we address this problem? And another way of looking at this is, look at the different growth rates. So system-level test is relatively small right now, but if it keeps growing up, say 14% CAGR, it's going to really pull the industry out of shape within a couple of years. So this is something that has to be addressed somehow. Oh, and by the way, our 14% CAGR is quite conservative. Most of the companies that we speak to, they're all talking about a 20% CAGR going forward. So if it's 20%, then the problem's even worse. The question is, what can you do to get costs down? So
John, there was a question, and I'm assuming this would be somebody who would love to buy your research if Do you have the breakout of the test cost trends by market or by end application? Because obviously certain applications could probably afford more in terms of test cost or have higher quality standards.
Yes, so these are overall numbers, and they tell just one part of the story. The really interesting stories are actually when you start digging down into those sub-segments. So there are some segments where costs are growing rapidly, and you're right. These are for high-end chips, for critical applications. Cost for them is, it's a problem, but it makes sense for them to pay the money because they have to. There's other end of the spectrum where it's generic legacy products. Costs are declining rapidly in those areas. So again, as a supplier of test sockets or probe cards, you really need to know, which of the markets to go after, which of the customers to go after, to really understand what's happening. So this presentation was just really meant to be just a general overview of pressure building up in the system as a whole. And yes, there are some very attractive markets within here that have got, where the customers are willing to pay a lot of money to solve their problems. So yeah, so you can see here that package test, burn-in test, wafer sort the next 5 years. It's reasonably healthy growth, that 3 to 5% range. But this system level test is going to challenge everybody, if this becomes a major cost for the industry. Now, one of the troubles we have is that, for us, we've only really we've known about system level tests, but it's been very difficult to measure. So we've just ignored it. It's like it wasn't there. But, clearly it's starting to get big enough to catch a lot of people's attention. And, one of the reasons why we didn't really pay attention to it was because it was quite small. We didn't know the suppliers. A lot of the equipment was generic or homemade. It was a mess. It was just didn't make sense for us to try and quantify this. But we do know that actually, as system level tests is starting to enter the mainstream. It's starting to attract companies that we do know, like the Advanced Tests, the Teradynes, the AEMs, the Chroma, and a lot of the socket suppliers are really starting to take a position in this industry. Now we're actually starting to get some real data that allows us to get some sense of just how big this market is. And our first estimate is this is going to be in excess of $1 billion, and that's a lot of money. That's part of that cost to test. And the other thing that we're also struggling with as analysts is to really understand, what are the dynamics of these costs? We kind of know what's happening with probers, ATE. We've got 20, 30 years experience of that. We know exactly what's happening there. But with system level tests, it's still relatively new and we don't fully understand this. So we do know that some companies have invested heavily in this in the last couple of years. Some smartphone manufacturers have put a huge amount of capacity in. But given that smartphone demand is kind of maturing and it's not growing very much, do they have enough capacity to last them for multiple years, or is this just the start of a huge capacity build-up? We just don't know yet. The other question is, which products need to be tested at the system level, and are they going to test a small sample, or are they going to test everything? And again, at the moment, it's moving away from sampling to mass testing. So again, how that plays out will also have an impact on how much money the industry spends on this. Test handlers, some of these are very customized. So when the product they're testing comes to the end of its life cycle, can you recycle or reuse, repurpose that test handler, or do you need to get a new test handler? Again, it's not quite clear how that's going to play out. And then efficiency gains, like we know with what happened with with semiconductor, with package test and with package test, you can test in parallel. And we know system level test is in parallel, but is there a limit to how much you can test in parallel? And of course, then also we don't know how much is going to go to the merchant market and how much is going to be kept captive with chip makers making their own systems. So there's a lot that we don't know. So our 14% CAGR at this stage is still an experimental number, but from everyone we've spoken to, we still think that's on the low side. So that's.
And we did have a question here is, you know, the spend on system level tests going up because the companies don't want to invest to test at the component at the wafer or package level?
No, this is additional. You know, there's only so much you can do at wafer. There's only so much you can do at package. Essentially, systems are getting so complex that the only way you can really test, you know, whether your product's going to work or not is actually at the system level. And I think that's becoming, you know, clear to anyone who's developing a product which is going to go in a critical system. You just have to do this. You can't afford, you know, and again, it's all of this mixing and matching and modules and everything else. You know, a lot of the, you know, especially like an Apple product, for example, you've got chips coming from multiple vendors, multiple places, and you know, the only way you can really be 100% sure is if you retest everything in a system. So yeah, I think this is here. This is an additional cost. There are some opportunities maybe for testing a little bit less at package or burn-in, but again, we've yet to see how this plays out over time. But yeah, we can expect to see some fairly innovative solutions to this.
So John, with a lot of that, is it tied into the advanced packaging market where you're basically having to do much greater thoroughness, much greater complexity? I mean, the known good die discussion of, is it really good? Is it not good? If you've got 10 chips in a module and you discover one isn't working, or the number of chips in the module really decreases the overall yield. I mean, is a lot of that driving this? And kind of in that context, sort of one of the other questions here is like, how does that really relate to like chiplets? Are we seeing these tested at wafer sort? Are we seeing them tested at package test? Are we seeing them tested at system level test?
Okay, so to answer your question, this is quite a rapidly changing environment right now, because there is no clear solution. I mean, the fact that the industry is spending over $1 billion tells you they have to do this. I mean, they wouldn't spend that money unless they had to. So it is becoming increasingly clear for some products or some systems, you just have to do the system level test, because at some point in the past, their modules, their systems have failed, and that's unacceptable. So they've got to do this. This is not a nice to have. This is pretty much becoming essential. So this is why I think this is here, and it's here to stay. And but still, again, as part of a test strategy, it's still unclear. We've spoken to a lot of people about this, and everyone's got different ideas. There hasn't been a clear path that everybody's following. It seems that there's still a lot of experimentation going on here. So again, going back to chiplets and things, yeah, it's a huge problem. Where do you test? How much do you test? And so on. It's all a challenge, and of course, it's all adding to cost. And at some point, this has to settle down. They have to decide on a final solution that works, and then they can start really trying to get the cost out of the system once they've figured it out. But I still think there's a lot of things changing right now. Okay. All right. So we kind of said that in summary, the system level test costs, it's around $1 billion, could be more, and we've got a growth rate of at least 14% over the next 5 years. So, clearly, this is a big additional cost, and as this enters mainstream, it's going to change the cost structure of test. Now, one of the things is, it's a critical problem. So, what can you do to get those costs down? So, obviously, one is change your test strategy. That's a topic for a completely different conference and probably a different presentation, and that's way outside my area of expertise, but that's one solution. And we know there's a lot of discussions going on right now about, what is the test strategy? what is my competitor's test strategy? Because everyone's trying to figure out what the right path forward is. So that's one thing, but that's outside of the scope of this presentation. Or the other one, the easy path to take is for buyers to look at their supply chain and try to squeeze it to get better prices and better products. But the thing is with both of these options is that they both involve a trade-off in risk. You change your test strategy, okay, you may lower your costs, but you may increase your risk. That's the same with suppliers. You can squeeze your suppliers, but the question is you really need to know which companies you should be squeezing and which ones that you need to take care of, because you could easily damage the supply chain. So I'll stick with this topic of squeezing suppliers. And the reason I'm doing this is that up until a few years ago, we really didn't have many chip makers contact us and ask us about the probe card market or the test socket market. They just didn't really need that information. But in the last 3 or 4 years, we're getting an increasing number of chip makers are buying our data, and they're taking advantage of our consulting, and they're saying, these are the kind of questions they're asking. They're not asking, how big is the market and what are the market shares? They're asking a completely different set of questions. They're asking things like, am I paying too much? Well, maybe, but I'd also argue you need to know if you're paying too little. If you're not paying enough, you could easily damage the supply chain. So the question here really is, what is the right amount of money I should be paying? Which would be one thing. Again, we're getting those questions. We're not happy. Our existing suppliers are kind of okay, but we'd really like to talk to somebody else because they're not being responsive enough. They're also trying to figure out, okay, we don't like any of the existing suppliers. Who else can we get into the market who might be good candidates that we could talk to? And then, they need to know each supplier's strengths and weaknesses. Which suppliers need a little bit of help, which ones need to be challenged a bit. And then finally, this is more of an interesting question, is the type of relationships the chip makers or the OSATs should be having with their suppliers. Is it a completely hands-off and just say, okay, let them get on with it, trust them to provide the right products at the right price, or do I hold their hand and give them a little bit of guidance, or maybe I need to have a more intimate relationship with them to really work very closely with them to solve some of the problems, or do I need to take those suppliers and really shake them up and force them to reduce their prices and improve their technology? So these are an interesting set of questions that we've been getting over the last few years, and they're all coming from buyers of probe cards and test sockets. But the thing is, we also know is that answering these questions takes more than just numbers. Numbers is only part of the story. Really, what you need to know is the information behind those numbers to really make better decisions. So what I've done here, in the interest of time, I'm just we've got a lot of information on how to do risk analysis for the industry, but I thought this is quite an interesting one, is to look at like a segment analysis market shares by vendor rank last year. So what this data shows is that for individual segments, so the orange ones here are ATE handlers and probers, what is the vendor share for the number 1 supplier and the number 2 supplier, number 3 supplier? If we look at a set of data like this, we can see for one of these segments, supplier, the number 1 supplier has 50% market share, and the number 2 supplier has 35% market share. So this is, a classic dominant supplier with a strong second source. And the question I always ask is this okay? Because when you look at this data set, you see 1 and 2 are looking pretty good, large market shares, but number 3 is way off in the distance with a share of between 5 and 10%. And the question is, what happens if your number 1 supplier fails to deliver? Okay, you can shift some of your demand to supply number 2, but supplier 3 is so far behind. There's no way they could ramp up fast enough to cover what supplier number one was delivering. So when I look at something like this, this is a classic, strong dominant supplier, strong second source, that's okay. I think certainly for the hardware, the industry needs to figure a way to get number 3 and number 4 slightly more share. Again, as an insurance policy, because if either the number 1 or 2 supplier can't deliver, then this could be a major problem for the industry. So in this situation, this particular situation, I'd suggest that probably chasing number 3 and number 4 on price is probably not a good strategy. You need to figure out ways to help those companies, improve and get a better market share somehow. So this is test hardware, showing you that it's quite consolidated already. And for very good reason. I mean, obviously economies of scale are very important here, but what if that number 1 supplier can't deliver? Okay, number 2 can only take up some of that. Number 3, no, they can't help at all. So there is a risk involved here. So looking at the test consumable side of things, so these are the blue lines. These are probe cards, sockets, interface boards. And this is very much more of a fragmented market with multiple suppliers. So you can see number 1 supplier, no more than 25%, very strong second, equally strong third, pretty strong 4th place. So in this situation, we've actually got, as a buyer, actually, I've got more power here. I can, if number 1 doesn't deliver the right product or the right price, I can easily switch to number 2, 3, 4, 5, or even 6. So there's a lot of choices here. So there's more scope here for some kind of consolidation, maybe, or maybe trying to squeeze your suppliers a little bit more on price because you have much more options here. But it's just knowing that for each of these suppliers, before you go after them for better pricing, you really need to understand where they are in the ecosystem, what it is they do really well, and make sure that you work with them in an appropriate way. Because for each of these segments, for probe cards and for sockets, for some applications, there is only 1 supplier. They have the right technology at the right price. There is only 1 supplier for that. So again, you need to look beyond this to really understand where the risk is in trying to push your suppliers for better pricing. So this is just a couple of examples of ways that you can use data to figure out, okay, where can I save some money? Who should I be talking to try and get those costs down? But of course, the thing is, it's never such a simple situation. The buyer's challenge is that their cost of test is going up, and they've got to figure out how to get it down. So they need the data, they need the analytics, they need the stories behind the data, so they can really figure out where you can manage the costs, and more importantly, where you can't. Where you actually need to invest and actually help your suppliers overcome some of their problems. But the other one, which we didn't talk about earlier, is really understanding how the risks are today, but really seeing how they change over time. How did that supplier get to 50% market share? Have they always had that, or is that a more recent trend? And if it is a recent trend, maybe next year they'll have 60%, maybe the year after it's 70%. Is that okay? I mean, these are the kind of questions you need to ask. And also with the supplier in 3rd place, were they a big company that are getting squeezed down? You need to know how these things are changing over time to really attack your cost problems. So some final thoughts here. This was all about the cost structure of test and how that's changing and what it means for everybody. The fact is this, with system level tests coming on, with wafer sort and package test costs going up, these challenges are here and they're not going away. The industry is not going to ignore these. They are going to have to figure out a way to get costs down. And they're going to come after the suppliers in quite a big way, I imagine, in the next couple of years. One of the solutions, clearly, and Jerry mentioned this earlier, you need this closer collaboration between suppliers and buyers. I mean, that would be nice, but historically we kind of know that that's always been quite a difficult relationship. It's not always successful, but you're going to find a way to get better collaboration. And again, finally, it's going to be tough over the next few years. So it's not about optimizing a solution. It's just finding solutions that everybody can live with. I think we're all going to have to compromise somewhere, to find a way through this. So with that, I'll stop talking and I'll answer any questions.
Thank you, John. We know we're a little over the scheduled end, but I see that there's lots of questions and I would like to get a few of them in. But before people take off, if you take a moment, I just launched the poll to give John some feedback. You should see that on your screen. So, John, is there? Let's take 3 or 4 of these really quickly. Is there any particular IDM or OSAT that you see that's really pushing the system level test growth that you can comment on?
Yeah, all of the companies you'd imagine, like I guess the Apples, the Intels, the Qualcomms, Huawei's, MediaTek. I mean, anyone who's in communications and high-end chips. Yeah. OSATs, I don't know. Yeah, it's still too early to figure out. I'm assuming there is some OSATs that have system level test capability, but for the moment, I still think this is still very much within the hands of the the chip designers that are so it's the companies you'd expect. It's not for everybody. I think some even some memory companies are in there looking at ways to test the SSD drives.
Mm-hmm. Another question, and I think, well, I'll read it the way it's written and then you can tackle it. You mentioned the reuse of handlers, which are typical for ATE, or what I would probably say is package tests. In this token, are you indicating that ATE will be reused for system level test as well?
We don't know yet. I say the way test handlers are configured, some are highly customized and they probably won't be able to be reused. Others more apparently customizable. Sorry, they are more adaptable. But again, I don't know exactly how much re-engineering, redesign has to go on to allow them to be used for other products.
Okay, got it. Here's a question. Asking, isn't the cost of test increase an obvious consequence of pushing the wafer fab geometry boundaries? That's part one. And then the same person's asking, is it true that the cost of tests will only go down if a manufacturer fixes their own process issues?
Yeah. Actually, that's a very good point. Yeah, it's tricky. Yeah, so I guess in the past there was always, if you could scale your chips down. There was always an economies of scale by going smaller chips, and if you go smaller chips, you can test them faster. Then there's lots of things you can do. But right now, one of the big challenges is actually test times going up. So these huge memory chips, I mean, it takes a long time to read and write to a huge NAND chip. I mean, that's just, it doesn't scale. So test times are going up, which is probably one of the reasons why this is becoming a problem. Yeah, I think the kind of solutions that we're kind of hearing about is using machine learning to really understand which die on the wafer are good, are very likely to be very good, and which ones need a little bit extra testing. So I think there's some smart things going on there where, if you know a chip that comes from the center of the wafer is 100% good always, and the chips around it are also always 100% okay, you don't have to do extensive tests on those, whereas the ones on the edge of the wafer, you may need to do more testing. So I think there'll be much more of this, rather than testing everything the same way, there might be a little bit more, but we know these chips from this part of the wafer need this, this amount of testing, and those on the edge might need a different amount of testing. So there's a lot of, again, a lot of work being done right now to figure out ways to at least reduce the amount of test that has to be done, but I don't know how effective that's going to be.
Got it. Okay. I think let's do one last one, and I think there's a reason this person asked anonymously. I think they probably don't want to start a fight, but you know, would there be more sophisticated solutions to reduce cost about the upstream process, like in a design phase, like a robust design to reduce test? So, you know, improve the designs, and then tests would not create value for customers, right? So I think that one's been argued. Jerry's laughing. You know, I can give a simple answer, but I'll let you take the first stab at it, John.
Yeah, I think for any new chips that are being developed right now, I mean, everyone's really at the ragged edge of technology. So, you know, the idea that you're going to get a perfect chip right off the bat, right off the design, just it's not going to happen. So to answer your question, essentially, it's yeah, if people further upstream did their job properly, yeah, they wouldn't need to do so much test. But the fact is that we're all running at the extreme levels. So that's why, you know, not through, yeah, I mean, it's just the way the industry is that no matter how hard you try, you're never going to be perfect. So that's why there's always got to be a test element in there. That doesn't change.
Yeah, there was a number of years ago at ITC, there was a panel discussion, and the title was "Test, No Value Added," and that was probably one of the most interesting discussions that I'd ever seen. So,
yeah.
Right. Yeah, and the way I point it out is, if you want, if you say it doesn't create value, you wouldn't be able to test. I mean, you wouldn't be able to ship memory devices, DRAM, flash, or FPGAs without test until those technologies could be totally self-testing and self-repairing. So I think being able to ship a product is value. So, okay. We've gone over, but I thank you very much, John. Thank you very much, Jerry. I thank everybody for attending. I thank everybody for sharing part of your day with you, and I hope everybody enjoyed it. And if there's any specific questions or feedback, please send it to us. We'd love to hear it, because like test, we will always want to improve. So thank you, everyone. Have a great rest of your day, and look forward to seeing you at a future event soon.